Okay, welcome back, calculus lovelies. Here we go again. I'm making a video on natural log and e to the x. These are some fairly straightforward rules. I'm also going to do a little bit of review of like implicit differentiation, a couple other things in here. So please just kind of follow along. Also, periodically, I'm just going to ask you to stop the video and try the problem yourself. It is very important that you actually stop and try the problem yourself first. Okay, so what I would like I would like to start with a review problem out of one of our packets. So I do want to present to you what packet we're working with, and then from there we are going to kind of go through a couple of things. So here you go. This is the packet that we're working out of. It's derivative of e to the x and natural log of x introduction notes. So we're just going to kind of introduce these two ideas and also review a bunch of stuff as we go through it. So the first thing I'd like you to do is stop the video right now, read this problem, and try to do the problem yourself, either in your notebook or on this paper. So stop now and try the problem. Okay, so here's what we're going to do. We're going to actually work our way through this problem. So let's review a couple of key things. Remember, anytime it asks you for a tangent line, you always need a point, and you always need the slope. Okay, two things every single time, except this time, they tell you where y equals 1. So don't let that fool you, because we just need to figure out then what the x is, rather than figuring out what the y is. So I'm going to use the original equation, and I'm going to plug the 1 in and see if this kind of works out for me. So I'm going to have x to the 8th plus 8 times 1 to the 5th equals 41 times 1, because remember, y equals 1, minus 32. So I have x to the 8th plus, well, of course, that's going to be 8. This is going to be 41 minus 32, okay? And 41 minus 32 is 9. So I have x to the 8th plus 8 equals 9. So subtract 8. So I have x to the 8th equals 1. And then you take the 8th root, and of course the 8th root of 1 is 1. So what point do I have? I've now calculated my point to be x is 1, y is 1. But remember, this can be plus or minus, because when you take the 8th root of something, it will be plus or minus of it because it's even. Okay? So it's going to be plus or minus 1. So we have two places where it's going to end up working out for us, or 2 points that we're going to have to work with. So let's go to the slope part. Okay, so the slope part is now going to do some things that we just did in the previous chapter, or the previous section. The previous section included implicit differentiation. Reason we have to do that is because we cannot isolate and get one y by itself. We're going to have like a y to the 5th and other things. So we need to get the y, we need to use implicit differentiation and then get the dy or the y prime by itself. So if you remember, when you do implicit differentiation, you just take the derivative of everything with respects to x. So we are going to take the derivative of everything with respects to x. So let's use the rule, x to the 8th. Well, that's going to be 8x to the 7th. And then we have dx over dx, which is 1. Okay? Now, then we have a thing with a y. Okay? It's going to be 8y to the 5th. Now remember, 8y to the 5th is going to be an implicit differentiation thing. So what's going to happen is we're going to use the rule. It's going to be 40y to the 4th. But remember, we have to multiply it times the derivative of y. So I'm going to use y prime because it's a shorter notation instead of writing dy over dx. Then I'm going to get 41y. So again, this is implicit differentiation. So you multiply 41 times 1. So you get 41. And then you still have to take the derivative of y. So that's going to be times y prime. And then, of course, minus 32, the derivative of that is 0. Okay? So this is now the formula that we have. Now remember, I'm trying to find the slope. So the slope is actually this part. If you're trying to find the slope, the y prime represents that slope for us. Now I'm going to show you a little trick that kind of helps make this go a little bit better because they gave us y prime or y1 already. So we know x and y already. So what I'm going to do is I'm going to actually, at this juncture, I'm going to put those values in. Okay? So I'm going to put 1 in for this. And then I'm going to put 1 in for y. So I have 40 times 1 to the 4th. But remember, I don't know y prime equals 41 y prime. Now, as I keep going through this, I can get the y prime by itself now with some of these numbers and kind of make it a little easier for myself. So 1 times 7 is 1 to the 7th power is 1, of course, and then 8 plus 1 to the 4th is 1 times 40 is 40y prime equals 41 y prime. So I now have to get the y primes by itself. So I'm going to move this over here. So I have 8 equals 1 y prime. So the slope of my value here is, or the slope of my function is 8 when we have the point 1, 1. But here's the thing. I also need to figure out what the slope's going to be for the other point. Because remember, when we did this, we have 2 points where this is going to be working. So what that means now is I need to do 8, and then x is negative 1 to the 7th, plus 40 times 1 to the 4th. And then remember, that's times y prime equals 41 y prime. So now the only thing that's changed is this part, this negative 1. And what's going to happen, though, is negative 1 to the 7th is, of course, negative. So now this ends up being negative 8 plus 40y prime equals 41y prime. And then now get the y prime by itself. And what that's going to end up being is negative 8 equals y prime. So we have 2 slopes at 2 different points. Remember, this is at negative 1, 1. So all of this work is required to figure out what the equation of the tangent lines are going to be, because now we're going to have 2 different equations. So for this one, it's going to be y minus 1 equals 8 times x minus 1. For this one, it's going to be y minus 1 equals negative 8 times x plus 1, because we're substituting in those values. So here is our first sample problem that now involves using implicit differentiation. Okay, so the next one is also kind of a review problem, but kind of not. We've only seen this about twice. So because of that, I decided to put this in here. So I want you to determine if this is differentiable, but I want you to show me the math for it. Okay, so stop your camera or stop your video and then try to do this problem. Okay, now the trick is at this juncture, you need to look at this a little differently because you need to think about what absolute value means. Okay, so absolute value is, if you take the absolute value, it's always positive, regardless of whether you're at a negative number or a positive of the same number. So it's always going to be positive. So when you're working with absolute value and you're trying to do math with this, you need to make sure you think of it as a piecewise function. Okay? In calculus, we're going to think of it as 2 separate piecewise functions. So the first one's going to be the negative of the function, and the second one is going to be the positive of the function, because whatever happens, if it's an opposite sign, it's going to change it to a positive. So we have to think of it as 2 very different, pieces, one on the negative side and one on the positive side. So as we go through and we kind of distribute everything out, this ends up being negative x and minus 5. And this ends up being x plus 5. Now, remember, if it's going to be differentiable from the left, it has to be the same slope as it is from the right, okay? But we should all know that all absolute value functions look like a v, so we know that at the right spot it's going to be, one's going to be negative and one's going to be positive. So let's just go through and do this. So if you're going to figure out if it's differentiable, you need to take the derivative of each piece, okay? So the derivative of this top part is going to be, when it's all said and done, the derivative of the top part is -1, okay? And then when you take the derivative of this one, the bottom one, it's +1. So when we look at this at x equals -5, okay, we'll notice that the two slopes are different. So this is going to be not differentiable. And then you would say because slopes from the left and right are not equal, okay? But the trick here is actually making sure that you think of this equation as a piecewise function, the negative and the positive of it. Okay, so now